Hello, my name is Diego Fernando. I'm studying in New Cambridge School and this is my first improvement activity. We're going to start with Thomson's experiment. He proposed the plant pattern model that was a circle with smaller circles inside it and that represent the electrons or the negative part of the atom. Also, he said that they are randomly put in the atom. How did he get that idea? He did an experiment with a cathode ray when he put a gas inside the cathode ray and the ray was visible. Then, to confirm his idea that the negative particles travel to the positive part of the cathode, he put a magnet below the cathode ray. In the negative part, the ray repelled, and in the positive, it changed its route. Years later, Rutherford, another excellent scientist, found a new model for the atom. He proposed the Rutherford atomic model. That was a circle with a small point in the center that represent the nucleus, and the orbits represent the electrons or the negative part. Also, he said that the atom has many empty space. How did he get that? He put a gold foil and he hit it with a ray of alpha particles. The ray passed the gold foil, but some of the ray come back, so he thought that the ray was positive and the nucleus is positive and they repel, and that is the reason for the ray come back. That is how he get that idea. Then another scientist, Paus is his name, proposed the electronic configuration, that is the model of the electrons of an atom in an atomic model. That is the image of the Paus chart. That is how do you get the electronic configuration. It has 4 groups that are S2, P6, D10 and F14. The big number says the shell number, the letter says the block, and the small number says the electrons in the shell. For example, we have the carbon with atomic number 6. His configuration, electronic configuration, is 1s2, 2s2 and 2p2. We can change the final number to take a result of the addition from the small numbers 6. For example, we have 2 plus 2 plus 2, that makes 6. We need that. If normal, p is 6, but we can change it for 2. Also, we can express it like 1 is 2, and below 1 we can put the 2, then the 3 and then the 4. That depends of you. Then we have the Lewis structure. That is a form to put the electrons of valence in the symbol of the element. For example, we have the carbon. The carbon has 4 electrons of valence, that are the electrons in the last shell. Another example is the magnesium, that have 2 electrons of valence. That is the image of the Lewis structure of the magnesium. Then we have the groups in the periodic table. We have 5 groups that are alkali metals, alkali earth metals, the block D, the halogens and the noble gases. The alkali metals have 1 electrons of valence. All the elements in the alkali metals have 1 electrons of valence, are very soft, and are in the group number 1. The alkali earth metal are the next group. The group number 2 have 2 electrons of valence and are harder than the alkali metals. Then we have the block D, that are all the transition metals, are very good conductors of electricity and heat. The valence electrons depend on the element because they are not stable. Then we have the halogens that are in the group 17 and are very stable. But finally we have the noble gases that are the most stable elements in all the periodic table. They are all gases and are in the group 18. His name is because they have the 8 electrons of valence in his last shell. For that reason they are very, very stable. Now we're going to see the reactions with water and acids in the group 1 or alkali metals. With water, the group 1 has a very aggressive reaction, except the hydrogen that is not a metal, and the lithium is the less reaction in that group, because when you increase the period, you are going to observe that the reaction is going to be harder. Then we have the acids. We have a formula for the reaction of acid in the group number 1. Here is it. The M is one metal, the number of the metal, and the H plus or the H2 is the acid. Finally, I'm going to talk to you about the reactions of the group number 2 with water and acids. With water, the alkali earth metals form hydroxide, and with acid, they reduce the acid to make hydrogen. That is the formula. Like in the other example, the M represents the metals and the H the acid. They don't affect 2 elements of the alkali earth metal, that are the beryllium and the magnesium, because they are not metal and they have a shell. Thank you for watching.